Welcome to this explainer, brought to you for VU3R Education Solutions. Today, we're cracking open a truly fascinating source document, a grade 7 science textbook. But hey, we aren't just going to sit here and memorize facts today. We're going to take a journey, starting from the broad, ambitious goals of this educational text, straight into the incredibly specific and fascinating physics of sound.
Okay, let's dive into this. Here is our macro to micro roadmap for today. We'll start with the value of education, explore a diverse science curriculum, zoom in on the physics of sound, analyze speeds in different mediums, and wrap up with light versus sound.
Section 1, the value of education, a societal investment. Right in the foreword of this textbook, there's this incredibly powerful quote. It says, "This book is a product of free education." You see, the authors want students to grasp, literally from page 1, that having these materials is a huge privilege. The government provides these textbooks directly because of the hard work, the commitment, and the labor of parents and elders. It beautifully frames the whole concept of learning as this massive societal investment. And so, what's the ultimate return on that investment? Well, the government is deliberately changing curricula to keep pace with the rapid changes of our technological world. The whole point, the core goal here, is to prep students to be productive citizens in a really complex future. We're talking about building a rock-solid foundation so these learners can navigate a landscape that's just constantly evolving. Section 2, a diverse science curriculum, scope of grade 7. To make that happen, the curriculum is structured into these distinct, highly focused chapters. Take a look here. Chapter 11, for example, is where it introduces the core concepts of sound. This kind of modular approach is brilliant. It gives students these focused, easily digestible blocks of information, but it's constantly building up their overarching scientific literacy at the same time. Now, let's walk through this table together because it really captures the sheer breadth of this grade 7 scientific universe. Check out how the columns group the chapters by discipline. Under biology, you've got students learning about nutrients in food and biological processes. Move over to earth science, and they're studying the atmosphere, soil, and minerals and rocks. And then, bam, in physics, they're tackling force and motion, heat and temperature, sources of energy, and of course, sound. It's just a fantastic 360-degree view of how our natural world actually operates. And this brilliantly illustrates the massive intellectual leaps these students are asked to make. On one hand, you're deep into biological processes, exploring the organizational levels of life. And right next to it, you're dealing with force and motion, distance, displacement, some really heavy physics concepts. It perfectly preps the mind to jump across disciplines, which sets us up beautifully to zoom in on our specific physics topic for today. Which brings us to Section 3, the physics of sound, what we hear. All right, so here is the absolute core concept you need to grasp. Sound is generated due to vibrations. It's such an elegant definition, isn't it? Whether it's a bird chirping outside, a radio blasting your favorite song, or literally just my voice talking to you right now, the fundamental rule is that without vibration, there is absolutely no sound. Every single thing you hear is simply a vibration interacting with your ears. But that begs the question, what exactly is vibrating? The text gives us some really concrete examples. Sound can be produced by the vibration of membranes, think of like a drum skin when you hit it, or strings like you'd find on a guitar or a piano. When these objects start to vibrate, they literally disturb the medium around them. That disturbance creates the sound waves that eventually travel to us. So how fast are those waves moving? Section 4, speeds in different mediums. How fast is sound? Now, what's really interesting about this slide is the absolutely staggering difference in speed depending on what that sound is traveling through. Check this out. In air, which is a gas, obviously, sound travels at about 330 meters per second. But if you move into a liquid, like water, that speed jumps dramatically. We're talking 1,500 meters per second. And in a solid, like steel, it rockets all the way up to an insane 4,500 meters per second. It turns out sound travels vastly faster and way more efficiently through tightly packed solid materials than it does through the air we breathe. Kind of wild, right? Let's put those numbers into perspective. Section 5, light versus sound, a scientific race. Consider this little everyday mystery. Think about event 1, lightning and thunder, or event 2, a cannon firing, pushing out smoke in a loud boom. In both of these events, the visual, the flash of the lightning or that puff of cannon smoke, and the actual sound are emitted at the exact same time. But if you're standing far away, you always see the lightning or the smoke seconds before you ever hear the thunder or the boom. Why is that? Well, the crucial point is this. It's a literal race between light and sound, and light is exponentially faster. As our text clearly points out, the speed of sound is just much slower than the speed of light. While sound is chugging along through the air at that 330 meters per second we just talked about, light is traveling so incredibly fast that it reaches your eyes almost instantaneously. In this race to your senses, the visual is always going to win. And that brings us to our final thought for today. What other everyday phenomena around you are governed by these unseen scientific rules? You see, the ultimate goal of this curriculum wasn't just to make you memorize the speed of sound in steel. The goal was to create curious, productive citizens who look at their world a little differently. So the next time you hear a sound, I want you to picture those vibrations. Think about the medium it's traveling through, and just appreciate the incredible science happening right in front of you. Thanks for joining me on this explainer, and keep learning.